Welcome to Pure Physics. Today we're going to see a very important topic related to class 11th and class 12, which is calculus. So, what is calculus? Now, calculus is a branch of physics or mathematics that deals with the study of change and accumulation. Now, what is this change and accumulation? Now, generally calculus is divided into two types. One is differential calculus and the other is integral calculus. Differential calculus deals with the rate of change of quantities or change in quantities, and integrals generally refers to the accumulation of quantities over an interval of time or any variable, or it is also the totaling of quantities over an interval of time. Now, this differential calculus will be learnt detailedly in this video, and this integral calculus will be learned in the upcoming videos. So we are going to learn about differential calculus. It has three main characteristics which helps us to study differential calculus. The first one is rate of change, the second one is slope, and the third one is instantaneous behavior. About these topics we will be learning deeply in this chapter. So what is calculus and why we need to use calculus in physics, and especially what is the use of differential calculus in physics. In physics we learn about velocity, acceleration, different physical quantities that we learn across physics change over a period of time or over an interval of time. So in order to calculate the change over that interval of time, we use differential calculus. So apart from the use of calculus in physics, there are three main things that we need to know before entering into this differential calculus. The first one is, what is a variable? What is a variable? What is a constant? And what is a function? So before entering into this topic, we need to learn these three main content. The first, variable. It is a quantity. It is a quantity that can change. It is a quantity that can change. Example, velocity, temperature, time, etc. And coming on to constant, by the name itself we can understand it is the quantity, that does not change. For example, we can give speed of light in vacuum, and we can also give the gravitational constant. So these are constants. Now what is a function? A function is mainly a relation. It is a relation that relates an independent variable with a dependent variable. Now coming on to this constant, now we are going to learn about the third topic of the three main contents of differential calculus, which is function. So how do we represent function? Now let me take y is equal to f of x. Here y is dependent on the x value. That is, y is called as the dependent variable, and x is called as the independent variable. Why do we call the y variable as dependent variable? Is because whenever we substitute x that will give the value of y. For example, let me take y is equal to f of x, and the equation given for f of x is like this. This is an example. F of x is equal to x square plus x. This is my equation. Now they are asking me to find the value, to find y, value of y at x is equal to 5. This is my question. How do I find y when they give the value of x equal to 5? Because I have a condition y is equal to f of x, where f of x is given as x square plus x. So in the place of f of x, I'm going to substitute f of 5. So wherever the x is present, I'm going to substitute the value 5. So in the place of x, I'm going to substitute 5 square plus in the place of x again 5. So my answer of f of 5 will be equal to 25 plus 5, which is equal to 30. My question is equal to y is equal to f of x is equal to f of 5. Because they have asked me to find the value when the value of x is 5. So when I substitute in the place of x the value 5, I'll be getting f of 5 is equal to 30. Therefore, my y value will be equal to f of 5, which is 30. So as the value of x changes, the value of y also changes. If I put in the place of x is equal to 2, my value will be 4 plus 2, 6. So like that, whenever you change the value of x, the y value will also change, because I have given the condition that y is equal to f of x. That is why we say y is dependent variable and it is dependent on the value of x. But x does not depend on the variable y, because y does not have any equation where x is dependent on the values obtained from y. So that is why x is called as independent variable and y is called as dependent variable. Now we are going to learn about what is change of quantity. What is change? What do you mean by change of quantities? Now let me assume that a car is moving on the road, and let the car be at point A and the final point is point B. Now the velocity of car from point A to point B will changing with respect to time. When time t equal to 0, the velocity was what? It was at rest, because it has not moved from at point A. So my velocity will be 0 meter per second. And at some point t equal to 5 seconds, the time taken to reach from point A to point B is 15 seconds. Let me take it as 15 seconds. Then my velocity of car at point at time 5 seconds is 5 meter per second. This is just an assumption. The value of velocity is just assumption, because at point A the car is at rest. As it moves from point A, the velocity will increase, and I am giving it 0.5 seconds, the velocity is 5 meter per second. So by the time, at every point of time, the velocity will change over an interval of time if it is not moving in uniform. So that change in velocity is called as change of quantities, or any other quantities, not only velocity, or any other quantities like temperature. If a temperature changes from 70 degrees Celsius to 80 degrees Celsius, or 70 degrees Celsius to 60 degrees Celsius, there is a change in temperature, so that we will represent it by a notation called as delta. This is a Greek word. This is the representation of the change in quantities. Greek symbol which represents change Okay, so whenever we write the change in quantities, we write the symbol and the notation of the quantities. Now let me take x. Okay, let me take x as a physical quantity, or it is a displacement. Let me take it as a displacement. A body is being displaced from x is changing from x1 to x2. How do you represent this change in displacement? You will just denote it as delta x is equal to the difference between x2 and x1 will give you the change. This will give you the change in displacement of the body. Now I have an example related to change in quantities. Now let me see. So this is an example for change in quantities. So the question is, a car moves from position x1 to position x2, and position x1 is at 20 meter, and it moves from 20 meter to 89 meter. Then what is the change in position? That is, let me take this as origin. And this is my 20 meter, and from this 20 meter, a distance of 89 meter, from 20 meter the car moves to 89 meter. So what is the change in its position? So at some point of time, the car is at 20 meter. From 20 meter, within a time interval, it is moving to a point where distance of 89 meter. So how do you find the change in position? I said, whenever you take change in quantities, you should always consider the final value minus initial value. That is, here my final value is x2, right? x2 minus x1. Change in position can be represented as, since I am using x1, x2, the position will be represented as x, and change in position will be delta x. Since I'm going to denote it as change, so I'm going to use delta value. So delta x is equal to x2 minus x1. What is the value of x2? In the place of x2, I'm going to substitute 89 meter, minus in the place of x1, I'm going to substitute 20 meter. So my delta x value will be 89 minus 20, which is 69 meters. So this is my change in position of the car. So now we are going to learn about average rate of change. What is average rate of change? It just tells us how much y quantity changes per unit change of x quantity over an interval. Let me take y and x as a quantities, and I need to know the average rate of change. How do you tell? Let the y quantity be velocity and x quantity be time. Now you're gonna find a truck which is moving. You need to find the velocity, change in velocity over an interval of time. At time t equal to, let me say at time t equal to 5 seconds, the velocity of the truck was 30 meter per second. Okay, this will be my first velocity, and this will be at my first time. At some later time t2, which is 10 seconds, my velocity changes from 35 meter per second. So from 30 meter per second, it has changed to 35 meter per second within 5-second gap. That, how do I say that 5-second gap? When I subtract t2 minus t1, I would get 10 second minus 5 second, which is 5 second. So this will be represented as delta t. So this is called as interval. So within this interval, the velocity has changed. So how do I get the average rate of change? Y changes per unit. Whenever the word per comes, you are gonna divide the first quantity with the other quantity. So I'm gonna find the delta V, the change in velocity over this time interval. That is V2 minus V1. Always you should take the final value minus initial value. My final value here is 35 minus 30, which is 5 meter per second. This will be my delta V. Now you consider this y quantity as velocity and this x quantity as time. Then you're gonna find how much velocity changes per unit change of time over an interval of time. How do we find that? We are gonna use this word per. Per is nothing but ratio between the change in y quantity and change in x quantity. So I'm gonna take average rate of change. Average rate of change is equal to delta y by delta x, which is delta v by delta t. What will be my answer? My delta v is nothing but 5 meter per second. So I'll substitute 5 meter per second divided by delta t is 5 second, which will be 1 meter per second square. What quantity will have this unit? What quantity will this unit will be designated? That is acceleration. So this will be called as average acceleration. Average acceleration will be 1 meter per second, because acceleration is defined as the first derivative of velocity with respect to time, or rate of change of velocity, or change in velocity with respect to time. So this is an example. I have assumed that y is velocity and x is time, but it is not necessary all the time y should be velocity and x should be the time, because this is an example so that we are using time and velocity. So y and x can be any physical quantities, and we can find the change in any physical quantity, and we can take the average rate by just taking their ratios and just assigning their units. Now this is my example for average rate of change. The question is, find the average rate of change. They have given me an expression or an equation, that is f of x is equal to x square at x1, 4 and x2, 6. Now this f of x is nothing but we are going to represent it by y is equal to f of x, because whenever x value changes, y value also changes. So y is dependent on f of x. So I'm going to take this as one condition. I'm going to substitute the values of x. So f of x1, which is equal to f of 4. It is x square. So in the place of x, I'm going to substitute 4 the whole square, which is 60. Now f of x2, which is f of 6, which is 6 the whole square, which is 36. So this is my y1 value. This is my y1 and this is my y2, since x is x1 and x2. Now I need to find the average rate of change of this equation. How do I find the average rate of change of equation? The definition is, it tells us how much the quantities of y changes per unit quantity of change in x. That is, delta y by delta x will give us the average rate of change of the quantities. Now here delta y by delta x is what? y2 minus y1. y2 minus y1 by x2 minus x1. Here y2 is 36. 36 minus 16 divided by the given x value is 6 minus 4. 36 minus 16 is 0 and 20. So 20 by 6 minus 4 is 2. And the answer for average rate of change of this equation is delta y by delta x is equal to 10. And you need to put units. So whatever units they have given in the question, you need to write. But here there are no units and no quantities have been mentioned. Just one equation, and they've asked you to find the average rate of change. So this is the example for average rate of change.